Now that we know the extreme value theorem, let's try it with some trigonometry. Our function this time is f of theta equals the cotangent of theta raised to the 2/3 power. Remember, this is the same thing as cotangent to the 2/3 of theta. We like to write it the first way because we don't need parentheses, but we like to write it this way because it reminds us of the chain rule. So first step is to find the critical numbers on the interval pi over 6 to 3 pi over 4. So we're going to take that derivative, which is f prime of theta. Power rule takes us to 2/3 cotangent of theta because the argument never changes, raised to the negative 1/3 times the derivative of the argument. Don't forget the chain rule. The derivative of the cotangent is the negative cosecant squared of theta. That's our derivative. We might want to clean this up a bit. We have a negative fraction. What's on the top? We've got a 2 on the top. We've got a cosecant squared on the top. And then we've got a 3 on the bottom. And we've got a cube root of cotangent of theta on the bottom. So the question now is, what are the values of theta between pi over 6 and 3 pi over 4 that cause this derivative to either A equal to 0 or B equal to undefined? So the numerator equaling 0 will give us a derivative of 0. The denominator equaling 0 will give us a derivative of undefined. So we're going to set both the numerator and the denominator equal to 0. We don't need the negative. We don't need the coefficients. All we need to worry about are the variable expressions. So the cosecant squared of theta equals 0. Well, remember that the cosecant is the reciprocal of the sine. And sine bops back and forth between 1 and negative 1. And I'm not sure we're ever going to find any value that when you take the reciprocal of it, we're going to get 0. So no solution here. Yeah. The cosecant graph goes between 1 and infinity, and negative 1 and negative infinity, but never between negative 1 and positive 1. So no solution there. All right, so no horizontal tangent lines, no places where the derivative equals 0. That's fine. We can keep on going. We're going to now look for values where the denominator equals 0. And that boils down to when the cotangent of theta equals 0. So thinking about cotangent equals 0, we know that that's going to happen at pi over 2 and 3 pi over 2 and 5 pi over 2. The only value between pi over 6 and 3 pi over 4 that's going to fit that description is pi over 2. All right. That's going to be our one critical number. By the way, I should have mentioned this at the beginning. F of theta is in fact continuous on this interval because the cotangent of theta is continuous between 0 and pi. So since this is a subset of 0 to pi, we know that this is going to be continuous. All right, so at any rate, now we are going to consider our endpoints, and we're going to consider our critical number. And those are the contenders for extrema. So we've got f of pi over 6, we've got f of pi over 2, and we've got f of 3 pi over 4. A lot of times people will ask the question, do we plug these values into the derivative or do we plug these values into the original function? Well, if we think about it, we're trying to find the extrema of the function, so we need to plug them into the function. Second of all, we already know what happens when we plug pi over 2 into the derivative. We get a denominator that's equal to 0. That's where that pi over 2 came from. So we already know that the derivative is undefined there. So let's use these input values for our given function, the original function, and then we're going to compare our answers here. We're going to take the cotangent of pi over 6. We're going to raise that to the 2/3 power. Well, the cotangent of pi over 6 is the square root of 3. So we're going to take the square root of 3 and we're going to raise that to the 2/3 power. Squaring the square root of 3 will give us 3, and then taking that to the 1/3 power will give us the cube root of 3. Moving on to the f of pi over 2. We're going to take the cotangent of pi over 2. We're going to raise that to the 2/3 power. Well, the cotangent of pi over 2, as we talked about over here, is equal to 0. So we're going to raise 0 to the 2/3 power. 0 to the 2/3 power is 0. And then, finally, we're going to evaluate the cotangent of 3 pi over 4. And we're going to raise that value to the 2/3 power. Cotangent of 3 pi over 4 we know is -1. When we raise -1 to the 2/3 power, we're going to square it and cube root it. And order doesn't really matter here, so either way we're going to get +1. So we've got a positive number, and we've got 0, and we've got a positive number again. So as far as minimums are concerned, we know for sure that f of theta reaches a minimum value of 0 at theta equals pi over 2. And then f of theta must reach a maximum, so it reaches a maximum value of either 1 or the cube root of 3. Well, the cube root of 1 is 1, and the cube root of anything bigger than 1 is going to be bigger than 1. So I guess since 3 is bigger than 1, then the cube root of 3 is bigger than the cube root of 1. So the maximum value of the cube root of 3, and where does that happen? That happens when we've got an input value, a theta value of pi over 6.